right atrium, which is here on the bottom in this diagram. This is not anatomically correct, but it's logically correct. So some students who are confused will sit there and go, oh, okay, the atrium's on top over here, therefore the atrium must be on top over here. No, this is a logic diagram. That's the point they keep stressing over and over. Don't get confused on that. So we have the right atrium. The right atrium then pumps the blood into the right ventricle. There's a valve that regulates the flow of blood from the right atrium into the right ventricle. And you guys hopefully will tell me that the name of this valve is the right AV valve. And then from the right ventricle, blood is pumped into the pulmonary artery, and there's a valve that regulates the flow from the ventricle, from the right ventricle into the pulmonary artery, and this is known as the pulmonic valve. So this diagram, which started out very simple, is becoming progressively more and more complicated. Now, here's a different rendition of what I've just put up over there on the board. So we're going to start out over here on the right side of the heart, and we're going to show blood coming back to the right side of the heart, emptying into the right atrium. Again, not anatomically correct, but I'm going to put up on top superior vena cava and down below inferior vena cava. And that's simply to represent that we've got these different streams of blood coming back to the right atrium. So this blood empties into the right atrium. There's a valve. You guys can look over there at that diagram. Hopefully all of you tell me that the valve that regulates the flow of blood from the right atrium into the right ventricle is the right AV valve. Something very important, do not lose sight of this. If you take a look over on the left side, I'm showing the leaflets, so they're oriented downward. On the right side, I'm showing the leaflets, so they're oriented upwards. That's not the anatomically correct position. Here, the leaflet is oriented downward, but here's what you have to appreciate. You have to appreciate the orientations of the leaflets. If this leaflet was oriented in the following manner, then would the right ventricle be able to fill with blood? And the answer is no, it would not, because when the right ventricle contracts, it would push this leaflet up in that direction and this leaflet up in that direction, and the two leaflets would come together and they would prevent the blood from flowing into the right ventricle. Everybody with me on this? This is logic, right? This is logic. You have to understand the logic of the leaflets. Over here, the same thing is true. Except here, if the right ventricle contracts in this orientation, it will exert a pressure on the leaflet, pushing it up. And on the opposing leaflet, it will exert a pressure on it, lifting it up. And the two leaflets come together, and that prevents blood from moving back into the right atrium. What do you think? Everybody with me, Ms. Sharon?
Yeah.
Good, because you get the next question. So here's blood coming into the right ventricle. The blood is then pumped via the pulmonary artery to the lungs. And this is the pulmonary artery. Mr. Wren, there's a valve here. Which direction are the leaflets pointing? Downward into the right ventricle or upward into the pulmonary artery? Like so. That's the correct answer. Logic says, Mr. Wren, that if the leaflets were pointing in the opposite direction, then what would happen to the flow of blood through the pulmonary artery? So imagine the leaflets pointing down into the right ventricle, and the right ventricle contracts. What would happen to the flow of blood into the pulmonary artery? What's that, Ms. Mullen? It would be blocked. That's exactly right, because as the right ventricle contracts and it produces a pressure, it would lift up on those leaflets, they would come together, and it would block or prevent any flow of blood up into the pulmonary artery. In this manner, imagine these leaflets are doors, and the door is closed here. And now the right ventricle contracts and it produces a pressure. That pressure pushes up on this leaflet, and it pushes up on this leaflet, and the doors open. And now blood is free to flow through the pulmonary artery until what happens? Let's see who can take lessons learned previously and apply them to this problem. Blood will continue to flow into the pulmonary artery as long as what condition is present?
No pressure difference. No pressure difference.
The pressures have to be different on either side of those leaflets, right? The pressure acting upward has to be greater than the pressure acting downward. If those two pressures are the same, what's the position of the valve? Closed. If the pressure acting downward is greater than the pressure here, what's the position of the valve? Open or closed? Closed. The only way we get those doors to open up is if the right ventricle produces a pressure that's greater than the pressure in the pulmonary artery. All right, this blood is circulated to the lungs, it becomes oxygenated, we remove the CO2 from it, and now blood comes back to the left side of the heart via the pulmonary vein. And it empties into the right, it empties into the left atrium. And you guys have already told me, based upon the drawing over there to your right, that there is a valve that regulates the flow of blood from the left atrium into the left ventricle. And the name of this valve that regulates the flow of blood between the left atrium and left ventricle, you guys are going to tell me, is the left AV valve. The blood then is pumped out of the left ventricle to all the cells in the body via the aorta. And the name of the valve that regulates the flow from the left ventricle into the aorta is the aortic valve. Now, one of the things we talked a little bit about, very briefly, but I just want to come back to it, is I want all of you to appreciate the right side of the heart is the low pressure side. The left side of the heart is a high pressure side. So there are conditions where the walls of blood vessels become weakened. What's the name of that type of condition or pathology, Ms. Cho?
I don't know, heart disease?
No?